a long time ago, wood was actually used a lot more than anything else because, like I say, I mean, trees grow faster than you can mine minerals. So for a while the there were more things made out of trees than there were made out of steel and metal. And also getting steel stable, it's not just one mineral that you have in the steel. It's a lot of different minerals all mixed in together, that make up this steel particulate that is better. If you look at it, it's a whole bunch of different little things like I don't know, brass and a lot of different minerals that make up that what makes steel steel. And I forget the exact details of it. It's been a long time, and realistically, I was more of a wood person anyway. Like I use steel for like the steam engines and like the car engines and stuff like that, but most of my money was actually in wood and timber, and like we used to use the wood for the trains, the hardwood. There were actually steam trains that were made out of wood, solid wood. Just great big, hardwood. Boxes, and we use wood a lot. And then with a two coat paint process, you didn't just put lead on the paint lead on the walls on the wood. You'd paint this other stuff, and then you would paint the lead on, and then that would create a moisture barrier that would stop the wood from getting wet and expanding. So as long as you keep wood perfectly dry, it won't expand. So there's this two coat paint process where you coat it with this one paint and then you coat it with this other stuff. And I think you have to do it while it's still wet, where it's still kind of sticky, and then the lead will stick to the surface, and then that provides, and then the lead is actually a metal, so it actually provides a moisture barrier, so the water can't actually get through to the wood, and then that keeps the wood from expanding, and then it won't crack, it won't break, and you can drive that in the rain, you can drive that wherever, you can fly through the rain, you can do it, and that'll last about 3 or 5 or 36 years, no problem, before you start having any problem at all. I think maybe forever. I don't know. Some of them lasted like 50 years, I think, or something like that, before they actually had a problem. There is some moisture because it usually eventually does get in somehow. Anyway, I don't really know. It was a long time ago. So we built steam pressed cars. We built steam pressed wood fenders. They're not actually carving the whole sheet. They cut it thin and then they press it into place. And they could actually do some really cool bends and stuff. I mean, wood was actually the wood process was actually really advanced. So we had a lot of wood, we used to protect it really well, and had protectors for that. Anyway, it was a long time ago. And later on, wood metal became more stable and more common. So there started to be more and more steel around and metal around. So trees grow faster than metal, and there's actually more of a possibility for wood. But trees have their limitations. You can only go so high with wood and stuff. And wood does eventually rot after like 10 or 15 years anyway, or like 100 years anyway. So, I mean, any building material, when you start getting up to the extremes, it starts getting a lot tougher, and things start getting a lot more complicated. And you start having to have to go with a lot more technologically advanced stuff. If you want to go up like 1,000 feet or something like that, in order to get those kind of heights, or like 900 feet, you got to do something pretty strong and pretty ridiculous. That'll last a pretty long time. Anyway, though, but yeah, started out with like cars and stuff like that, and steam trains and some wooden trains, some wooden steel steam trains. Even some wood steam trains. I mean, we used to use wood for just about everything, where you just have a coal box and then the actual pressure box was actually wood or something like that. But they didn't last that well. So, they could last like 3 or 4 years, no problem. But I mean, after a while, it becomes like, wood and water don't really mix, and and so steam and steel and all that, so Lucifer Star went with the paint and the wood and all that stuff. So that's why there's like Star Mining, Star Mine, Star Timber, Star Pine, White Star Lumber Company. I actually had quite a bit of money and had a lot of people working for me. So anyway, And then, like JFK, Nixon, Jimmy Carter, John McCain, they tried to, they had guns, so they tried to take it all away from me and have me killed or hold me hostage or something. So, I mean, ow, little thing in the back. Anyway, so anyway, yeah, but yeah, I mean, I named Louisiana, Lusitania. I own the Titanic, the Olympic, you know, the Norton class, or I named the HMS Rodney, and a couple other ships. I also did the first aircraft carrier. You know, I thought that aircraft could land on a ship, and they were like, "No way!" And I was like, "Yeah, way!" And I happened to have like a 300-foot or a 400-foot long ship or something like that. So they tried landing a biplane on it, and then using a steam catapult, which I had a leftover steam catapult from like the V2 rockets. Like we were trying to get scramjets to work, and a scramjet has to be moving like pretty fast before it'll ignite. So they'd go and it would just go right past, and then the scramjet would actually light. But we needed like some really fast moving steam catapults. So my Germans were working on it. I was paying a lot of money, and we got it to work. So then later on with the aircraft, I was like, well, why don't you use a steam catapult? I got one. I mean, I researched it and invented it. I mean, I paid for it, so we got one. So why don't we put it on the ship? And they're like, oh yeah, let's do that. So we did it, and it worked, and we were able to just launch aircrafts. Like, I think the first time they launched the biplane, they said it just about ripped the wings right off the damn thing, because the steam catapult was set up for doing the V2 rocket. It's a scramjet rocket, so it goes, and it's got to be moving like 120 miles an hour or like 300 miles an hour. So they took one of these little biplanes, was like, okay, launch it. Rip. Just about. Because it was built for the V2 rocket. It was built to launch a scramjet engine. They put this little biplane on there, and it's set up for the V2 rocket. And so I just about laughed my ass off, because I was like, yeah, it was set up for scramjets. You might want to twist that knob down. There's a knob on it that sets the pressure. And I was like, yeah, that's that knob. You turn it down a little bit, and you should be able to launch the biplane, no problem. So, yeah, I was like, yeah, it'll launch, no problem. I mean, they just got the thing and put it on the ship, and they had no idea what it was built for. Like, yeah, it's set up to launch at 120 miles an hour or 400 miles an hour. It was like this really ridiculously expensive thing, and they just took it and put it on the ship, and then I was like, yeah, it was set up to launch scramjets. You might want to turn that knob down a bit. So, anyway, apparently it ripped the wings right off the biplane. So anyway, yeah. So that's what the steam catapult was actually invented for, was for the V2 rockets and stuff like that. And I had like 3 or 4 or 5 of them laying around, and they put one on one of the ships, just mounted it, and then put it in place and put the deck on top, and then went to launch the biplane and some other biplanes. And it's like, yeah, no problem. I mean, it'll launch it like right off. Like you could just take it almost vertical, and that steam catapult will just go. It was designed and invented by Germans, and some English, and they built it really friggin' well. It's built to launch V2 rockets, scramjet rockets. So it could launch them vertical, it could launch them horizontal. You could just take that thing, just, and they would launch. Anyway, I forget exactly how it worked exactly, but it was like this really cool. Like it cost me like 20. Like $2,000 back in like 1,500, or like $800 or something, or $900 back in like 1,500 or something like that. It was a really expensive, really technical thing. So anyway.